Okay, today we're going to look at chapter 4. Okay, chapter 4. So chapter 4, we will look at beam. Today we look at beam. So we already clear spring, we already clear bar, truss. Today we're going to look at beam. We're going to look at beam. So in chapter 4, we're going to look at beam stiffness matrix again. Then we look at assembly of a beam system. Then after that, we're going to look at two scenarios. One is concentrated load and distributed load. Okay. Now for the first session, we're going to look at development of equation, how we derive the equation for beam structure. All right. So, okay, what is beam? What is beam? So beam is a special scenario where we have a long element subject to a force, and we will have a transverse loading that produce bending effect. Okay, bending effect. So we will have a bending effect, and also we will have a twisting effect. So we have we will have a bending and twisting effect for beam. So just to let you know, we already study spring structure. This is spring. Okay. So spring only have displacement in one direction. All right. And we also study about beam. This is a beam. Sorry, not bar. Okay. And bar is only two end. Okay. There's no bending. There's no y direction. Okay. So spring one direction. Bar like that, and then we also study the truss structure. Okay, the combination of bar to a wall or something. All right. So this is the truss structure. And then spring, you have also assembly of spring lah. Okay. So you can replace with either one of these member as a spring. So we have also discussed about the tutorial, some question about spring and bar and truss in previous example. So today we're going to look at beam. So beam, we will start looking at the bending effect. We will see twisting effect also. So as you can see from your diagram here, you will have a member or element that will change shape, and you're having a two node again, two point again. Okay, point 1, point 2. And then your axis will be y and x. Later we will look at x and x prime again, but we will start look at the basic one. So point 1, point 2, and you will look at axis y and x. Okay, point 1, point 2, y and x, the length of L. And if you look at point 1 and point 2, there is something different compared to the spring and bar. If you look at the force is not same like the spring and bar or truss. Spring and bar, the forces is at both ends, and normally is to one axis only, for example, x-axis, right, along the structure. But if you see when it's become beam, if you look at the force, you look at the diagram, the force is in vertical direction or in y direction. Okay, so for beam, we will have y F1y vertical. For beam point number 2, we will have F2y. So since we are having a force in y direction, so we will have a displacement. Okay, we have displacement in y direction because you push along y-axis. So your displacement will be v. Okay, so for beam, you will be using v instead of u. So for spring and uh, bar, you use u if it's along x-axis. Okay, so same with the spring lah. Spring, if this is x direction, so you have a u direction. However, for beam, you have y direction. There's no u direction. There's no x direction. So for beam, your displacement will become v, and since you have a force at both ends, you need to recall what is moment or what is torque. So this is your reference plane. This is point A, and you have a force. If you have a force that you have an arm or distance d, and this force is perpendicular to the reference plane here A, so the result of F times D, you will get a twisting moment in this direction. You'll get a moment at point A in this direction. Okay, so that's why you will get moment at point 1 because of F2. Okay, so you can see that this one, the moment at point 1 is because under the effect of F2y times L, you will get M1. Yeah, start recall this concept that I draw on the right hand side of your screen. So moment M1, you can find by taking F2y, because it's 90 degree to this point, right? F2y is 90 degree to this point. So it will create this direction, the moment in this direction, moment in this direction. Then if you look at point number 2, you also have a moment. Okay, you also have a moment created by F1. Okay, so of course you will see that the moment, if you generate that by F1, it will swing this way. However, in the development of equation, we will assume the direction as anti-clockwise. Okay, so what you need to pay a little bit attention is on the direction of the arrow for all the component. Just pay a little bit more attention to that one. Okay, so direction is that you're paying attention to y direction for beam. So F1y, V1, and M1, and you have an angle. You have a twisting angle of phi or pi 1. Okay, pi 1, or we can name it as theta if you want. But this one represent as a twisting angle. Okay, there will be an angle that you because of this bending, you will see some angle at this point. All right. Okay. Now before we proceed, let me see the attendance. Okay, Brian's still not here. Okay. Asmal, are you there?
Yes, sir.
Asmal, can you explain what is the difference between what do you understand about the beam differences between beam, spring, or bar or truss? How do you differentiate when this is a beam problem, or this is a truss problem, or this is a a bar problem? How you differentiate it?
I think that how to say the effect of the certain load to the structure.
Okay. So what is the direction? What is the difference of direction? What are some differences of direction if you compare maybe truss bar to the beam? Or what is the differences?
I'm not really sure, sir.
Okay. Never mind. Can repeat that again. Sue, are you there?
Yes.
Can you explain what is the differences between spring or bar or beam? How you differentiate a beam problem
I
to a
think
truss?
it's the dimension. For beam is have only the y, and for the bar is have x and y.
Mm-hmm.
I
Mm-hmm.
think it's like that one.
Mm-hmm. Mm-hmm. Okay, then there's one. Okay, Chia, what do you think? How you differentiate? This is a beam problem or this is a bar problem. How do you know?
I think for spring, uh, I'm not sure how do I differentiate.
Okay, never mind. I can repeat this one many times until all of you can understand. So, okay, when you study spring, is spring. I will move. I will change only sides when all of you able to repeat the same thing that I mentioned, explain. So this is x direction. Let me redraw that. So spring, when it's subject to force, is x direction. All right. So when at a spring, the load that when we derive the equation for spring, we assume we're having a tensile loading at both ends. Point 1, point 2, this is your F, force at both ends. So since this is a X, so displacement, okay, still go back to F equal to KD. So if you study about spring, your displacement will only have U if you're referring to X. Okay, U1, U2. What happens if you having a bar structure? Bar structure will always represent by a line. Okay, this is a bar structure, or you represent by a line. So you will have X direction, and you will have Y direction. Okay, so you are acting a force at both ends also. So we assume that this structure is having a tensile loading. So point 1, point 2, force at point 1, force at point 2. Okay. So since this member is moving along x-axis, so you will have U1. And if you're referring to F1, if there's an angle between the member, then you will have U2, V1, right? So you have V1. So in this case, because it's along x-axis, so we don't have V1. But if this angle, if this member is slanted at a certain angle, then you have X and Y. So in this case, you have U2, V1, V2. So in this case, we don't have V2 because it's along X-axis. However, it will be different if you have a member that is having a degree. Then you have U1 and U2. Now, we already explained what is spring and bar. So when you find your F equal to KD, you have different K and D for spring and bar. When you study about beam, if you look at the diagram and you compare the two diagrams that I draw on the right-hand side. So for beam, the definition, the beam is a structure member that produce significant bending effect as opposed to twisting effect. So if you can see from diagram, we have Y and X axis. However, the forces we have here is only the Y direction. So since your force is acting in Y direction, your displacement is moving along Y axis. So you have a V. Okay. Same with point number 2, you only have Y direction force, so you label F2Y. The displacement will be V2. Okay, now since you have a force at both ends in Y direction, and you are learning about physics, in physics, when you have a reference planes A, and you're having a force going parallel to this plane, and if you take the arm D times force times D, you get a moment effect or twisting effect. Torque or moment. That's why from this point 1, you have a moment 1 here because of force number 2. And if you stand at point number 2, you're seeing point F1y that produce moment also. So that's why for point 1, you're seeing moment 1, M1, and the twisting angle theta 1 or pi 1. Okay, so as you can compare to 3 scenario here, you should see the differences. Okay, Chia, you understand the differences between spring, bar, and beam?
I don't understand the difference between spring and beam, not beam, the bar, because why spring is only subjected to X direction?
Okay,
I can't get it. What if the spring gets slanted at the angle?
okay, all right. Now, if you have a spring at a slanted degree, okay, and if you are pulling at both ends, you're pulling at both ends. There's a force at both ends. Theta. Okay. Now, even though for spring, if you slanted, our reference planes will always follow the force. If you are looking at spring scenario, okay, because spring can own what if you seen a spring before, right, Chia?
Yes,
Yeah. So when you pull on the spring, at both ends. How do you operate spring? You can only operate spring by pulling at both ends, right? You can't like push from this end, right? Like this. If you operate spring, even you push like the green color direction, it doesn't the spring doesn't do anything. It does because spring what we focus on spring it will because we use the Hooke's law that this spring can either compress or extend in this direction. Correct? Yeah. Now, yeah, they might be, you can say that, yeah. So if you we look at individual component now, of course, when you combine the two, okay, let me erase the diagram below. If you combine, okay, if you look at individual, it'll be like this. If you combine beam and spring together in one system, then only you will consider the y or x for, let's say you're given a reference plane like that, x and y. Okay, so and then you're given an external force like that for a bar and spring system. Okay, so you're having point 1, point 2, point 3. Okay, so when you process the spring in this scenario, you pull this spring out, you'll be seeing is act only on y-axis. So you're having a V is only have one direction only, but it's along the body of the spring. Okay, but if you look at the component number 2, the bar here, the bar, if you have an external force at point 1 and spring is movable, so it's going to have a displacement in y direction for point number 2. And point 1, let's say you are having a pin here, then there's no movement at point 1, and they move at point 2. Okay. Now, what happens if I add another spring here? And then the spring with a 45 degree. And even I have, okay, let's say I add another pin that mounted to the wall. This is point number 4. So spring element 3 here, the spring here is slanted by 45 degree. Even though the F is acting in this way, but for spring, it only take action that is axial to its body. So for this element, you only look at this, the purple color plane. So what you do, you need to change this force. You need to split this force to like this. So that when it act on this spring, the only force that can act on this spring is this direction. This is the force that convert from this F. Force, this is F cos 45. Force cos 45 will be acting on the yellow color spring. Okay. Yeah. So this is the differences between yeah. So if you analysis about the spring or bar at 45-degree, you need to be careful on the direction of the forces. Okay. But what is important is that you're seeing the force acting on the body is along the body of the axial direction of the body. You can see the differences between beam and spring and bar. Chia, do you see it now? Chia, are you there?
Still not that clear, but get some idea.
Okay. All right. Now, today, the first session, I want you to have a clear mind of what is beam and compare to the spring and bar scenario. Look at the force, how the force act on the body itself. Okay. Try to understand how the force can act on the body or on the element. As you can see from what I draw from here, for the spring, the force will go along the body axis, or we call it axial axis. For the bar also, the force will go along the body, the force. Okay, even you slanted 45-degree, the forces will go along the body, but you need to change to axis. That's why we have a cos and sine equation. Okay, but don't confuse with the cos and sine yet. You just look at the force, how the force act on the body compared to the beam. If you look at the beam, the forces act on the beam is on y direction, which is perpendicular to the body. If this is a beam, sorry. Although I use a bar, okay? Although I use a bar, but if the force, if you look at the question, if the force that you have in the question, let's say 0.1, there's a force like this. This is the axle of the body. Then this one will become beam structure, will become a beam problem if your force is perpendicular 90-degree to the body. You compare again to the spring, bar, and beam. Chia, you understand now? Can you see the differences? Focus on the force direction. You understand, right? Okay. Ashmal, can you explain the differences between spring, bar, and beam? What do you understand about the spring, bar, and beam?
For the spring and bar, the force only acting on the what we call the axis x and y for on the structure. When it comes to beam, we got the moment bending.
Okay, how you get the bending is because of what?
Because of the what you call, we have the moment, the force that I think create the moment.
Like for example, how you get moment 1? Why there's a moment 1 at point 1? Why in this diagram there is a moment 1 here? Why?
Because F1 and F2 are parallel to each other.
Can you repeat your answer again?
Because the F1 and F2 is parallel to each other.
F1, F2 parallel. Okay. So your
when
mean
act,
you okay. So your meaning is as long as F1 and F1 and F2 is parallel, then it can generate moment, is it?
yes,
So what happens if I have this case? F2y, F1y also parallel. What? Will this generate moment? Will this generate moment?
I think no.
Mm. So how this moment 1 can generate if how this moment 1 can be in this place when you say that F1y and F2y is parallel? What does this diagram tell you on the right hand side, on the left hand side of this one? What do you understand from this diagram?
The what we call it, the at the for example, if we want to get the moment at point A, it happened because of the we have the distance and the force perpendicular to the distance.
Okay. So for this diagram, on this diagram, why there is a M1 here?
Because of the F2 is acting perpendicular to the length.
To the length.
Yeah, to the L.
F2y acting on the length, or is acting on the point 1? You need to be sensitive to what you use. The wording is a little bit confusing.
Yeah, I'm not sure how to explain it.
Okay. You don't know how to explain. It's very challenging. You're going to be engineer later on. You're not able to explain moment. How you get moment? How you get moment? Okay. Let's start with the reference plane. On this reference planes, I have a point A. And let's say I have a force. This force is parallel to this reference plane. Okay, this force is a reference plane. So when this force is parallel to this reference plane, and if I stand at point A, and this point A is, we have a distance, or we call it arm. This force, when this force is perpendicular to this reference plane at point A, then the products of F times D, you will get torque. Ashma, do you understand?
Yes, sir. Meaning that the parallel force is perpendicular to the point A. Is yeah.
So the torque can only generate when you have a force with an arm, with the arm or distance that is perpendicular to the reference plane. The distance must be 90 degrees. Meaning, if this is your reference plane, this is your force, the distance D must be 90 degrees to this point. Between the D and the force, mean this one, these 2 points, the distance between the force and A must be 90 degrees to each other. This arm or this distant line, this line must be 90 degrees to each other, so that the product of F times T, you can get a torque. So just now, Asma, you mentioned the force is parallel to F1, F2 parallel to F1. So what do you mean just now is that your force is at here. When your force is parallel to A, it doesn't create moment. Do you see the differences between what you explained just now?
Yes, sir.
So, can you explain what is the differences between spring, bar, and beam? What do you understand from all our discussions so far? What do you understand about bar, beam, and or how do you know that you are looking at beam problem or you are doing a beam analysis?
For beam, the force is only acting on the body, on the X plane.
So what is the, okay, so beside force, because of the force, what is the additional things that you can see on the diagram that compare to spring and bar that you never learned before? What is the new parameter that you see on the screen here? What is the differences between the spring, bar, and the beam? As you can see from the screen here, what is the differences that you never see in spring or bar chapter?
I think it's the
What?
The movement.
Movement.
No, the torque.
Torque or what? There's a torque. Another word for torque is what? Chia, can you help Sue a bit? What is this M? M1 represent what?
Moment.
Moment. Okay, good.
Moment. Okay.
Okay. So as you can see, or another way to explain beam problem, if you compare to spring and bar, you will be analyzing the moment and the angle, the twist angle. These are the two new things for today. If you see spring and bar, you don't have moment and twisting angle in your answer. In your F equal to KD, in the displacement here, you will not see moment or twisting angle in spring or bar. Maybe I explain that way. Then you can see it more clearly. Tia, you able to understand if I explain in that way? You never see M1 and theta 1 or psi 1 in a spring and bar, right? In the previous tutorial question, do you see these two?
No.
No, right? Okay. So these are the differences between spring, bar, and beam. Okay. Just now, Sue, you mentioned one thing is that they will be a force in x direction. However, this x direction do not contribute to moment. Okay, let me use the blue color. They can be a force along. You can have a F1x here. You can have a F2x here. You can. However, this F1x and F2x does not help to the moment and twisting behavior. The angle and moment 1. Angle 1 or moment 1, angle 2, moment 2. This F1x, F2x does not generate moment. Or you cannot, or there's no torque in the structure if you have a F1x, F2x. Okay. So do you see now? The blue color F1x or F2x does not generate moment.
Yes.
Tia, you agree with this one? F1x, F2x. If it's along this member body or in x direction, it do not contribute to M1 or theta 1 or M2 theta 2. Tia, do you agree? Okay. So I hope everyone clear what is the differences between spring, bar, and beam problem. Okay, just to summarize, for spring, okay, I'm writing F equal to KD. If you compare side by side, the differences between spring, bar, and beam. For spring, you look at it, when it comes to D, you only have one. U1, U2, let's say you have 2 points. For bar, you also have, for bar, it can be different. From bar, normally in a simple case, you only have same U1, U2. Okay. But normally for bar, we will have V1 and V2 for bar. Because this one can extend. This one can extend. But for beam, something different from these two, when you calculate F equal to KD later on, for the D, when you come to beam problem, you'll be seeing moment and theta 1 or theta, twisting angle. This is the main difference when it comes to beam problem. Meaning how you get moment, it is because of the opposite forces that you learn. Forces that can generate torque is because of this arm, F times D, that is 90 degrees to the reference point A. This one will generate torque or moment. Okay, so as you can see from this diagram, at point 1, why there's a moment 1 there? Because there's a F2y that have a length of L that is perpendicular to this point. The L is perpendicular to point 1 and point 2. That you match the diagram that I draw above. Okay. All right. So I hope all of you understand the differences between the previous chapter and this chapter. All right. Let me check the attendance again. Okay, Brian is here. Brian, when you log in, what do we discuss just now?
So you're discussing the spring, the beam, and the bar.
Okay, so okay, so from what our 45 minutes discussion just now, Brian, this question is for you. Can you explain or can you spot the differences of beam compared to spring or bar? What is the biggest difference? How do you know that you're answering a beam problem? In your answer, what do you see? What is the biggest difference?
So, actually, Jamal said that the beam, if you can go back to the previous drawings that you.
No, if you look at the screen now, the answer is on the screen. The biggest difference of beam compared to spring and bar. I mean, in the previous chapter 1, chapter 2, and chapter 3, you learned about F equal to KD, right?
Yes, sir.
So just now I mentioned about the D displacement. So
Yeah.
what is the biggest difference of beam when you solve for beam problem? What is the additional information that you need to consider when you solve for beam? What is the additional parameter that you need to put in the displacement component? The D, F equal to KD, the D component. What is the additional parameter that you should put inside the D component? It is here. Additional D inside here. What is the additional things that you should see when you know that you are solving beam problem? Okay, Brian, what is your answer?
So the displacement.
Yeah, the displacement. What is inside there? What is additional information compared to the spring or bar?
What the
answer is on the screen for your info. I even circle it.
Okay. So for this one, we have the moment.
And what? You only correct half.
And the angle.
Correct.
Theta.
Correct. So this is the only this is the only special things that when you know that you're answering beam problem. Okay. When you answer beam problem, you're going to see M moment and the angle, twisting angle, pi or theta in your D component. Then you are knowing that you are solving beam problem. Okay. When you solve about spring or bar, you will not see moment or angle of twisting in your D section. It is right over here. In your displacement, you will don't see M and theta or twisting angle. All right. Another differences between significant difference between spring and bar is that the K. If you look at the K, spring is quite direct, where you have a positive K, minus K, and K for spring. However, for bar, you have AE over L and 1 minus 1 minus 1, 1 for bar. However, today we're going to beam a little bit different from these two, but the main differences is at the D component, the displacement component, F equal to KD. In the D, you will see moment and twisting angle. Okay, yeah? So make yourself clear before we move forward the next slides. As long as you're able to tell that you are doing or you're solving beam problem, then you are all right. I don't wish to see you confused between spring and bar and even beam. Okay. Because there is a specific equation for spring, bar, and beam. Okay, yeah. So for beam, you have a moment and twisting angle. how you get this twisting angle, because the characteristic of beam that the force of Y is generated at both point here. So you have M1 is because of F2Y. You have M2 here is because of F1Y. So yeah, you can have a loss of other forces on the body. For example, you can have F1x here, but 1x is in x direction. F2x also appeared in x2.2 here. However, these two forces will not help on the moment 1 and twisting angle, because this one is acting along the body of the structure, and it do not contribute to the happening of your moment or torque. Because how you get your moment, you need to, there's a moment when the force is perpendicular, the force direction is parallel to the reference axis, and the moment of the arm, or D, the arm of the force, is perpendicular to the reference axis. The D must be 90 degrees to each other. The D here, the distance from here to here, when you draw the line must be 90 degrees to the force and 90 degrees to the reference axis. Okay. Right, so this is an important concept, moment. If you're doing your FYP, there's a lots of question that you need to solve using moment. All right, you need to deal with moment later on when you do your FYP final year projects later on. Okay, either you use simulation software, or you're doing design, or you're doing some analytic analysis on material, or solve a technical problem. You cannot run away from moment. Okay. All right. So for these slides, I will stop here and I will go for a short break.